Hi everyone, it's Mr. Bowman again, and this video is about inverse trig functions. So just to remind you, with trig functions you enter an angle and you get out a ratio, y over x, x over y, y over r, etc. For the inverse trig functions, we will put in a ratio and get out an angle. But before we get to the specifics on that, I want to talk about some ideas here. So think about this question. If I tell you the value of the sine, cosine, or tangent of an angle, can you tell me the exact angle I am thinking of? Take a moment, look at the unit circle here in this picture, and think about that question. To answer that question, let's take a look at a specific sine value. So let's say the sine is equal to 1/2. And you're here looking at the unit circle and you're asking yourself, does that mean that that specifies a particular angle? Well, if you just look at the unit circle here at an angle of pi over 6 radians in the first quadrant, the sine is 1/2. But it is also true that at 5 pi over 6, the sine is 1/2 as well. So in terms of the sine, if I tell you the value of the sine, could you tell me the exact angle? The answer is no. Let's try the same thing for the cosine. So let's pick a cosine of root 3 over 2. Again, that puts us at an angle in the first quadrant of pi over 6. The cosine is the x-coordinate for the unit circle, root 3 over 2. But you will also notice that an angle of 11 pi over 6 also has the same x-coordinate or the same cosine. So for the cosine, it's also not true that if I told you the value of the cosine that you would be able to tell me the exact angle, because there's more than one. Finally, let's take a look at the tangent and see if that works for the tangent. Well, we're going to use pi over 6 again, and if you looked at the value of the tangent is y over x, and 1/2 over root 3 over 2 simplifies to 1 over root 3, which rationalizes to root 3 over 3. Well, it turns out that as long as your x and y coordinates both have the same sign and they are root 3 over 2 and 1/2 respectively, then they are going to have the same tangent. So an angle of 7 pi over 6 has the same tangent. So basically what we're saying here is if I tell you the value of the sine, the cosine, or the tangent, you cannot tell me the exact angle that I am thinking of. And we can confirm that by looking at graphs of the sine and the cosine and the tangent. And you will see, for example, the sine is 1/2 at a value of pi over 6, and 5 pi over 6, and negative 7 pi over 6, and negative 11 pi over 6. And the cosine is equal to root 3 over 2 at pi over 6, and negative pi over 6, 11 pi over 6, negative 11 pi over 6, and so on. And the same thing is true for the tangent. The tangent is equal to root 3 over 3 at pi over 6, and 7 pi over 6, and negative 5 pi over 6, and negative 11 pi over 6. One way to think about this relationship between the angle and the trig ratio is in terms of inverses. And it's been a while since we've done inverses, so I want to remind you how they're related to each other graphically. So what you see here in this graph on the left in red is the sine function. So let me trace out the sine function for you here. The sine function in red like that. And the line y is equal to x in green like that. And if we reflect the sine function over the line y is equal to x, what we have in blue here is the inverse of the sine function. So what you notice is that the inverse of the sine function doesn't pass the vertical line test. So it's not a function in its current form. In other words, if we put a trig ratio in, we're going to get more than one possible angle out, which is what we witnessed on the unit circle and the graphs above. The same thing is true for the cosine function to the right of it. If we trace out the cosine function in red, and then we reflect that over the green line, y is equal to x, we will get the inverse of the cosine function, but in its current form, it also is not a function because it doesn't pass the vertical line test, which again means that if we put in a cosine ratio, we will get out more than one possible angle. And then the tangent function, same idea, just a little bit more complicated. The tangent function, the graph is shown in red, so I'll draw a couple periods of that. And we draw in the line y is equal to x, and we reflect over the line y is equal to x, and we get all these blue graphs here, which are the inverses of the tangent. But again, you can see that it does not pass the vertical line test. So if you were to put in a particular tangent ratio, you would get out more than one possible angle, which is what we saw above. Well, we don't like that as mathematicians. What we like is to be able to put in one value and get one value out. So what we're going to do is we're going to take a look at restricting the inverse tangent, sine, and cosine so that they are functions. And there are an infinite number of ways that we could do that. Basically, what we need is we need for them to pass the vertical line test. So basically, mathematicians have settled on the following. They have restricted the inverse of the sine to work from negative pi over 2 to positive pi over 2. And if you do that, you will see that it passes the vertical line test, in which case we can now call it a function. The inverse cosine, the restrictions are from 0 to pi, and then that would pass the vertical line test, and we could call it a function. And for the tangent, the restrictions are from negative pi over 2 to positive pi over 2, and then we can call that a function as well. So if we make those restrictions, then we can legitimately call these inverses functions. And this is the relationship and the notation that we use. So if f of x is sine x, then f inverse is equal to sine inverse of x, which is also called the arcsine of x. In other words, if you put in an angle into f of x, you'll get out a ratio. If you put a ratio into f inverse of x, you'll get out an angle. The same thing is true for the cosine and its inverse, and the tangent and its inverse. And all 6 trig functions have inverses. So as an example here, let's say we were to plug in pi over 6 to the sine function. We would get out the ratio of 1/2. That means if we were to take the inverse sine of 1/2, we would get pi over 6. Similarly, if we were to take the cosine of pi over 6, we get root 3 over 2. But if we were to take the inverse cosine of root 3 over 2, we would get pi over 6. And we can see with the tangent a similar thing. If we were to take the tangent of pi over 6, we have 1 over root 3, or root 3 over 3. And if we were to take the inverse tangent of root 3 over 3, we would get pi over 6. So now that we can plug in trig ratios and get only one specific angle, we can call the inverses functions. However, this does create some problems. Take, for example, the sine of 5 pi over 6. The sine of 5 pi over 6 is 1/2, so shouldn't the inverse sine of 1/2 be equal to 5 pi over 6? Well, no, and the reason is because when we plug in 1/2 into the inverse sine function, we get out pi over 6. We don't want to put something in there and get two possible answers out. We want the inverses to be functions. So this is not going to work for us. That's why we put the restrictions on the inverses to begin with, so that they are functions, so that when we put in a trig ratio, we only get one angle out. This, however, creates some problems for us, because when we're using them in applications, we may want to be thinking about one of the angles that is not given by the inverse trig functions. So we have to keep that in mind when we're using them. So when you're using the inverse trig functions, be aware of the restricted ranges. It's only going to give you an angle within a certain interval, and take those restrictions or limitations into account when using them. So before we send you off with all this powerful information, we probably need to practice this a little bit. And to practice this, you need to know the restrictions on the inverse trig functions. The restrictions on the sine inverse are from negative pi over 2 to positive pi over 2. In other words, if you use the inverse sine, you will only get an angle between negative pi over 2 and positive pi over 2 inclusive. That's in the fourth quadrant or the first quadrant, if you're thinking about it graphically. If you're using the inverse cosine, you will only get an angle from 0 to pi, which is going to be an angle in the first quadrant or the second quadrant. If you're using the inverse tangent, you will only get an angle between negative pi over 2 and positive pi over 2, because the tangent is not defined at negative pi over 2 and positive pi over 2. And the inverse functions, the inverse of the reciprocal functions also have restrictions on them as well, which we don't use quite as often, but since we're talking about it, let's see what they are. The inverse cotangent, unlike the inverse tangent, which gives you an angle in the first or the fourth quadrant, the inverse cotangent gives you an angle in the first or the second quadrant. The inverse secant gives you an angle in the first or the second quadrant, but it will not give you an answer at pi over 2 because the secant is undefined there. And the inverse cosecant will give you an answer in the fourth or the first quadrant, but not at 0 because the cosecant is undefined there. So the next thing we're going to do is we're going to do a few practice problems. And to keep things simple, we're just going to look at one at a time and think about how we should interpret these. So, inverse sine of negative 1/2. Another way of thinking about this is going to give me an angle, and that angle, according to my chart above, needs to be between negative pi over 2 and positive pi over 2 inclusive. And so I'm thinking of this as what angle between negative pi over 2 and positive pi over 2 has a sine of negative 1/2? And that is negative pi over 6. In the next one, you're thinking what angle between 0 and pi over 2, or pi over 2 and pi, so basically in the first or the second quadrant, has a secant of 1. Another way you can think about this is what angle has a cosine of the reciprocal of 1, but the reciprocal of 1 is 1, and so you can think about that in terms of the inverse cosine, and the inverse cosine of 1 is 0 because the cosine of 0 is 1. In this next problem, we want to find an angle that has a cotangent of negative root 3 over 3. This one gets a little bit tricky because its restrictions are noticeably different than the inverse tangent. So if we use the inverse tangent, basically what we're saying is what angle has a tangent of the reciprocal of negative root 3 over 3, which is negative 3 over root 3. But then we have to keep in mind the restrictions on that. So what angle has a tangent of negative root 3 over, negative 3 over root 3? That is negative pi over 3. But the inverse cotangent will only give you answers or angles on the interval from 0 to pi, and our answer right now is in the fourth quadrant, not in the first or the second quadrant. So we're going to add pi radians to that and get 2 pi over 3. That's a tricky one. What angle, number 4, between 0 and pi in the first or the second quadrant has an angle of negative root 3 over 2? Well, we know that would have to be in the second quadrant because the cosine's negative, and that angle would be 5 pi over 6. In number 5, what angle has a cosecant of root 2? If we go back up to our table up there, the cosecant basically is in the first or the fourth quadrant, which is similar to the sine, inverse sine, which it's related to. So we are going to take a look at it that way. Inverse cosecant of root 2, similar to inverse sine of the reciprocal of that, 1 over root 2, which is the same as the inverse sine of root 2 over 2, which is pi over 4. Now we should check and make sure that that angle is within the interval that's allowed for the inverse cosecant. Pi over 4 is allowed for the inverse cosecant. And now we get into some of these combinations or compositions of these functions and their reciprocals. So we treat these the same way we treat any other composition. So in number 6, we're going to find the angle on the interval from negative pi over 2 to positive pi over 2 that has a sine of negative 1/2. Well, that would be negative pi over 6. So we replace sine inverse of negative 1/2 with negative pi over 6. And then we take the cosine of that, and the cosine of that is root 3 over 2. Number 7, the cosecant of the inverse tangent of 1. So we are first trying to find an angle on the interval from negative pi over 2 to positive pi over 2, because that's the restrictions for the inverse tangent. That has a tangent of 1. That is pi over 4. And then we're going to find the cosecant of that. And the cosecant is the reciprocal of the sine. So the way I think of it is find the sine of pi over 4, which is root 2 over 2, and then take the reciprocal of that. And then it's often rationalized as you see here. Number 8, we're going to take the cosine of negative 2 pi over 3 and then take the inverse cosine of that. Now this is an example where people often make a mistake with that, and what they do is they make the mistake of thinking that those two cancel each other out because they're inverses of each other, and they do not cancel each other out. And the reason for that is that the inverse cosine will only give you an answer in the first or the second quadrant, and negative 2 pi over 3 is in the third quadrant. So I see I have a mistake here. I'm going to fix that right now as we work through this. This should say cosine inverse of cosine of negative 2 pi over 3. So the first thing we do is we find the cosine of negative 2 pi over 3. The cosine of negative 2 pi over 3 is negative 1/2. The inverse cosine of that, the way you should interpret that is find an angle in the first or the second quadrant that has a cosine of negative 1/2, and that is 2 pi over 3. So don't assume that when you compose a trig function with its inverse that they automatically cancel each other out. They do not, and that is because of the restrictions on the range of the inverse trig functions. All right, and then we'll do one more here, and then I'm going to let you practice on your own. So the inverse cosine of negative root 3 over 2. So find me an angle in the first or the second quadrant that has a cosine of negative root 3 over 2. Well, you can verify that that's 5 pi over 6. Now we're going to multiply that by 6, and you will see that these 6's cancel out. So then we're going to find the cosecant of 5 pi. 5 pi is coterminal with pi, so it's on the negative x-axis. And the cosecant is the reciprocal of the sine. So I think of this as 1 over the sine of 5 pi, but any point on the x-axis is going to have a sine of 0, so 1 over 0, which is undefined. Hopefully that gives you some insight into the inverse trig functions and how careful you need to be when you're using them. On the next page, you will find several more practice problems. I recommend that you take some time and you try and work through those, and then you check your answers. One last thing that I forgot to mention while talking about this was using the calculator to find the values of angles given the trig ratios. There are 3 built-in functions: the inverse sine, the inverse cosine, and the inverse tangent. So for number 11 and number 13, it's as simple as putting the calculator in the correct mode, radians or degrees, whatever you want your answer in, and hitting the inverse sine, inverse cosine, or inverse tangent button, and you can do that by hitting second and then the corresponding trig function. Plug in the number you're given, like in number 11, 2/3, and get out the answer in radians or degrees, and I would recommend you try those. The ones that are tricky are like number 10 and number 12. There is not an inverse cotangent button on your calculator. And number 12, there's not an inverse secant button on your calculator. So let's take number 12 first, and then we'll move on to number 10, which is actually a little bit harder. The secant is the reciprocal of the cosine. So if I'm trying to find the inverse secant of 1.99, what I can do is I can find the inverse cosine of 1 over 1.99, and I get 1.04 radians, or about 59.860 degrees. Now, one of the things you should do when you do that is you should go back and make sure that you've met the restrictions on the inverse secant. So 59.83 would be in the first quadrant. If we go back to the restrictions on the inverse secant, we can have a number between 0 and pi over 2. That's in the first quadrant. We're good with that. The tricky one is this inverse cotangent. Similar to the inverse secant that we just did, if you want to find what angle has a cotangent of negative 6.1, then you can take the inverse tangent of 1 over negative 6.1, but the inverse tangent will give you an answer between negative pi over 2 and positive pi over 2, and you can see that in the chart up here. However, the inverse cotangent will give you an answer between 0 and pi. So inverse tangent, fourth or the first quadrant, inverse cotangent, first or the second quadrant. So if we look at the inverse tangent, we will get an answer in the fourth quadrant because that's where the tangent is negative, and we have to add 180 degrees to that, or pi radians. So 2.98 radians, which is about 171 degrees, you will see that those are both in the second quadrant, which meets the requirement for the inverse cotangent button. That's it. This is not something that comes quickly. It's something that takes some time, so you're going to have to practice. You're going to have to ask lots of questions about this.